the operation of the center tap full wave rectifier. Consider a 120 volt AC source connected to a 10-to-1 step down center tap transformer. The center tap terminal may be considered at a potential of 0 volts. So we can note that right now. So here, so at this point, we can consider as 0 volts, which is this point here, or what we call the common, which is 0 volts. Now, we have 120 volts in, 120 volts AC, and it goes through a 10-to-1 step-down transformer, so we divide by 10, and we get 12 volts. So here, across here is 120 volts, and across here is between here and here is 12 volts. Now, because of the center tap, between here and here we 6 volts, between here and here we 6 volts. Okay, right. Now during the first half cycle, let's draw the half cycle. Let's draw the cycle. So this is the AC input, and let's prepare to see what happens at the DC, the DC output. Right. During the first half cycle, the top of the supply is positive, which means that also the top of the transformer is positive. And between here and here are the output. Positive at the top here and negative at the bottom. Right. Now, so you note that you have positive here, positive here, positive here, negative here. So across the transformer, this side is positive, this side is negative. Now, since we have center tap, right, this point is considered 0 potential. Therefore, this point here, connected D1, will be positive, and this point here, connected D2, will be negative during the first half cycle. So let's write those in. So here, during the first half cycle, here will be positive, and here will be negative. Good. Now, this means that D1 is forward biased during the first half cycle, right? So during the first half cycle, because D1 is forward biased, current will flow through D1 down through the load and back to the source, right? Because current is flowing down through the load, the top of the load will be positive, the bottom will be negative. So during the first half cycle, the DC output would be a positive pulse. Would be a positive pulse. Now, what happens during the negative half cycle? During the negative half cycle, the top of the supply will be negative, bottom will be positive. The top of the transformer will be negative, the bottom will be positive. You get negative here, positive here. As a result, you get positive here, negative here. Now, D2 is forward bias, and current is going to flow through D2, down through the load, and back to the 0 point. Note the current is flowing downward, so you get positive at the top, negative at the bottom. Okay? So, in recapping, during the positive half cycle, the current flows through D1 back to the 0 reference point. During the negative half cycle, during the negative half cycle, okay, in the negative half cycle, so let me negative half cycle, right? Current flows through D2 down to the load, and we get a positive output. So as a result of during both half cycles, the voltage across the load is positive, so we get a positive output voltage, and we get a pulsating DC output, right? Hence we have full wave rectification. Now the key thing about this circuit is the center tap. This circuit must have a center tap to split the voltages, so that on one half cycle D1 will be forward bias, and on the second half cycle D2 will be forward bias. So the key point here is this transformer is center tapped. The overall effect is that you have an AC input going in and you get a pulsating DC output.